This video goes over the length of the line segment investigation. So using GeoGebra, you can plot the 3 points listed there. They will give you an isosceles triangle that looks like, or a right triangle that looks like this. And then you are asked to find the lengths of AC and BC. You should get 4 using the GeoGebra tool. Then you can use the Pythagorean theorem to calculate the length of AB and check that it matches the value that you got when you were using the GeoGebra tool. So AB squared is equal to 4 squared plus 4 squared, which would have given you root 32, which you can evaluate with your calculator to get the decimal. Number 5 asks if the length of AB would change if the right triangle was formed by locating point C above point A. What that means is that you're going to leave your A and B points the same, and you're going to move C so that it is up here, really to the, let's say, to the left of A. So the length does not change, okay, because AB is in the same spot. So we can extrapolate on that to find a general format. To get the length of a line segment, we need the length of this side, which is going to be the distance between the y-coordinates. We also need the length of this side, which is going to be the difference between the x-coordinates. We have a right-angled triangle by doing that, and we know that our hypotenuse, or the length squared, is equal to the length of the shorter side squared plus the length of the other shorter side squared. We can take this further to put the square root on the right-hand side. So we've got the length of the horizontal component, or the horizontal line, plus the length of the vertical line here, which will get us the length of the line segment. So now there are 3 examples below, just using that formula. So the length between C and D, so we've got x1, y1, x2, y2, so we can put those in. You've got x1 minus x2 squared plus y1 minus y2 squared, which is going to give us minus 8 squared plus minus 6 squared, which will give us root of 100, which simplifies to 10 units. Second example, same thing. Our first point is x1, y1, second point x2, y2, and we're going to put those values into our equation. So x1 minus x2 squared plus y1 minus y2 squared, and then we can continue through here. So minus 5 squared plus 3 squared, and then we've got 25 plus 9, which would give you root 34 units. You can leave it as an exact answer or continue further using your calculator. Our final example is G, x1, y1, and H, x2, y2, and we're going to put those into our formula. 4 minus 3 squared plus 5 minus 1 squared, which simplifies to 7 squared plus 4 squared, which would give us 49 plus 16, which simplifies to root 65. You can leave as an exact answer or simplify further using your calculator. This formula is the key piece to take away from this investigation.